Yeah, sure. All right, this is going to be an explanation of question 5A from page 68 in the textbook. Someone from the class has requested it, and so I'm going to make a recording trying to explain. The gist of the question is you're given a parabola, you're given a quadratic equation, and there is a line without much information, but it does tell us that it's supposed to be a tangent to the curve. So here it is. The equation given is y equals negative 2x squared plus 5x plus 4. There is a line with a slope, mx plus b. There's a line with a slope of 1, and I don't know what the y-intercept is, and it's going to be tangent to the parabola. So how about I call the parabola f of x, just for clarity. And I'm going to call the straight line g of x, just to separate the two, okay, so we don't get confused. Okay. This is before. If it's going to be tangent, that means there is a situation where f of x and g of x are going to be equal to each other. In fact, they're going to be equal to each other at one location only. That gives us a clue of what our result will be for the quadratic formula when we deal with negative b over 2ac. You'll see what I mean in just a second. So that's for the sake of laying out the equation, I'm going to make 2x squared plus 5x plus 4 equal to 1x plus b. Right? And again, just like our other practice questions, I'm going to simplify it because if we can make this entire parabola, or sorry, this entire polynomial equal to 0, we have some clue as to what it's going to look like. So this is my a value. This is my b value. And remember, the c value is whatever the constant is. So right now, b is some number I don't know, but I do know that together, c is going to be 4 plus b. Let's apply that to our discriminant. Remember, if the location is, there's only going to be one point of intersection, that means when we do our, x equals negative b plus minus square root b squared minus 4ac over 2a, this portion underneath the square root is going to have to be a 0. It has to be. So that our negative b over 2a gives us only a single value. If we had this to be some kind of positive number, then negative b over 2a would have been added by a number to give you one possibility, or subtracted by a number to give you another possibility, and that is not what we're looking for. There's our clue. Our b squared minus 4ac has to be a 0. So let's do it. B squared minus 4ac must be a 0 if we have only one solution. That means b squared minus 4 times a times c has to be a 0. That means 16 plus 8 times 4 plus b has to be a 0, which means 16 plus 32 plus 8b has to be a 0. 8b has to be negative 48, and b, therefore, must be negative 6. That's great. What's b again? I know it was a little confusing that this is a b and that's a b. I know it's a little confusing. Sorry about that. But the b that we're dealing with originates from the constant or the y-intercept of the linear. Think about where it's coming from. The b I'm talking about is not this, okay? This b refers to this b, so it's just a code for the discriminant. Sorry if that confused you. But the equation of the straight line would be g of x That's equal to 1x minus 6. The y-intercept has to be negative 6 if I want the parabola to be tangent to the line. And if I could draw this very carefully, negative b over 2a, negative b, negative 5 over 2, negative 5 over 4, something. I think the parabola is something like this. I might be shooting myself in the foot. But anyways, it's just one location. I hope that solves the question for you. See if you can use this sort of solution as a template for the other questions you have in number 5, B, C, and D. Okay? I will stop the recording here.